Everyone, I am Satyam Kumar, a physics teacher. Today I will teach some topics of capacitor. So I am going to find the capacitance of parallel plate capacitor when a dielectric slab of thickness T is inserted between the two capacitor plate. Okay, so get ready. Okay, see. Find the capacitance of parallel plate capacitor when a dielectric slab of thickness T is lesser than D, where D is the separation between the two capacitor plate, is inserted between two capacitor plate. Okay, so this is our topic today. For today I will find out the capacitance of parallel plate capacitor when we insert a small dielectric slab in between the two capacitor plate. Okay, so see, suppose this is what? This is positively charged. This is positively charged capacitor plate. This is negatively charged capacitor plate. Okay. Now separation between these two capacitor plate is D, and the thickness of the capacitor plate dielectric slab is a small t. So see, this is what it is connected to battery. This is connected to our battery. Two plates of the capacitor is connected to battery. Okay, current is going from here. So when we connect two capacitor plate with a battery, this will become, since it is connected to positively charged terminals, so it will become positively charged, and this will become negatively charged plate. Okay, now when we introduce or insert a small dielectric slab whose thickness is a small t, then due to polarization of the dielectric, what will happen? Here negative charge will introduce negative charge will induce in this, which is near to the positively charged plate, and here positive charge will induce on this side of dielectric slab due to polarization. charging by induction, okay, due to polarization, here positively charged and here negatively charged. On this side negatively charged charge will appear, and this side it will become positively charged. Okay, now due to polarization of the dielectric. Now see, earlier when there were no dielectric was inserted, then external electric field was E naught. Okay, E naught was the external electric field when no dielectric was inserted. Now here here opposite charge appear inside the dielectric slab, so external electric field will decrease. When we introduce dielectric slab between the two capacitor plate, external electric field will reduce. Okay, external electric field will reduce. Suppose external electric field V, direction of the electric field inside the dielectric slab is from negative to here, it will be external electric field, so it will be from here this direction. It is what? Electric field inside the dielectric slab, and this E naught is what? External electric field. Okay, so electric field, net electric field will reduce. Now let V be the potential difference between the two capacitor plate when dielectric slab is inserted. Let V be the potential difference, V be the potential difference when a dielectric slab of thickness T is inserted. So potential difference is what? Net electric field into distance between the two. See, it is what? Suppose it is T, so this much will be what? D minus T. So for D minus T, see, this much is D, this much is T. So between this, it will be electric field is external electric field E naught. So it will be what? External electric field E naught. How much is the remaining space? It will be D minus T. So this is what? D minus T. Okay. Now again, electric field into thickness, electric field inside the dielectric into thickness. This is the electric field inside the dielectric slab, and T is the thickness. So you will use it. So it will be what? E into T. Correct? So this is what? Potential difference between the two dielectric slab. Now E is what? What is the electric field inside the dielectric slab? When we introduce a dielectric slab, electric field, external electric field will decrease, and inside the dielectric slab, electric field will be E, which is equal to E naught by K. Okay, E naught by K. Now we move ahead. Now we will substitute the value of E. So V is equal to E naught external electric field D minus T. Okay, and E is what? E naught by K into T. Okay, we substitute the value of E is equal to E naught by K, because where K is what? Dielectric constant. K is what here? K is dielectric constant. Okay, K is the dielectric constant. Now see, so V will be what? External electric field E naught D minus T plus T by K. Correct? So this is our potential difference between the two capacitor plate when dielectric of slab thickness T is inserted between the two. Now what is the electric field? What is the electric field between the two capacitor plate when no dielectric slab is inserted? This is the external dielectric field, external electric field. So it will be sigma by epsilon naught, because each capacitor plate, see, each capacitor plate behave as infinite plane charge sheet, and electric field due to infinite plane charge sheet is sigma by 2 epsilon naught. Each capacitor plate behave as infinite plane charge sheet, and electric field due to infinite plane charge sheet is sigma by 2 epsilon naught. So it is what? Due to positively charged plate, electric field will be sigma by 2 epsilon naught. Okay, where sigma is the surface charge density, and due to negative plate, again it will be same, sigma by 2 epsilon naught toward the negative plate. So this is what? Sigma by 2 epsilon naught. So inside the capacitor plate, net electric field will be sigma by epsilon naught, where sigma is the surface charge density. See, this is what? Away from positively charged plate, this is toward, so both are in same direction, so they will get at. So net electric field between the two capacitor plate, net electric field between two capacitor plate, is sigma by 2 epsilon naught due to positively charged plate, and plus sigma by 2 epsilon naught due to negatively charged capacitor plate. Both are in the same direction, so they will get add, and it will become sigma by epsilon naught. Okay, so sigma E, what is E? This is net electric field E naught. Okay, so E is the total electric field between the two capacitor plate, which is equal to sigma by epsilon naught. Okay, now we'll move ahead. Now so we will put V is equal to what? Sigma by epsilon naught D minus T plus T by K. Okay, this is our potential difference, where sigma is what? Surface charge density. Sigma is what? Surface charge density. So sigma is what? It is equal to surface charge density, means total charge by area. Surface charge density means total charge divided by area. Okay, now we will put, so V is equal to Q by A epsilon naught D minus T plus T by K. Okay, capacitance of the parallel plate capacitor C will be what? C will be Q by V. this I want to find out. This capacitance we want to find. So this will be what? Q by V. So this will what? V. Okay. You substitute the value of potential. So it will what? Q by V. V is what? Q divided by A epsilon naught. Okay. D minus T plus T by K. Okay. Now this Q cancel out. A epsilon naught, this will go up. Okay. So C is equal to A epsilon naught D minus T plus T by K. Now this is what? This is the capacitance of parallel plate capacitor when this is the capacitance of parallel plate capacitor when dielectric slab of thickness T is inserted between the two capacitor plate. So see, when we insert capacitor plate when we insert dielectric slab between two capacitor plate, capacitance increases. Okay, capacitance increases. So see, now when the dielectric slab of thickness D, means when the dielectric slab is completely filled the capacitor plate. Okay, means when dielectric slab is completely filled the capacitor plate, then what will happen? When T is equal to D, that is when dielectric slab completely fill the space between two capacitor plate. Okay, so T will put T is equal to D, then what happens? Going to explain. See, so C is equal to A epsilon naught D minus T. T is what here? T is D minus D plus D by K. Okay, so this D minus D 0, D minus D 0, and this is D, and this K will go up. So it will what? K A epsilon naught by D. Okay, now see, this value is what? This value is when this is the capacitance of parallel plate capacitor of thickness when the separation between the two capacitor plate is D. Okay, so we can write K C naught, where C naught is the original capacitance of parallel plate capacitor when nothing was inserted between that. Okay, when we insert a dielectric slab of which completely fill the space between the two capacitor plate, then the capacitance of parallel plate capacitor will increase by K times. So C is equal to K C naught. This is where K is greater than 1. K is greater than 1. Okay, so when we insert dielectric slab, that fills completely, then capacitance of parallel plate capacitor will increase by k times, k times. Okay, so this is how. That means when we introduce a dielectric slab which completely fill the space between the two capacitor plate, capacitance of the parallel plate capacitor will increase by k times. Okay, this is what original C0 is the original or initial capacitance of parallel plate capacitor. This is the new capacitance of parallel plate capacitor when dielectric slab of dielectric constant k is inserted between the two capacitor plate. Okay, now what will happen when conducting slab is inserted between the two capacitor plate, that I am going to explain. Okay, capacitance of parallel plate capacitor, capacitance of parallel plate capacitor when conducting slab of thickness T is inserted between two capacitor plate, okay, between two capacitor plate. When conducting slab is not dielectric, conducting slab is inserted between two capacitor plate, what will happen to capacitance? Whether it will increase or decrease, by what factor it will increase or decrease, that I am going to calculate. Okay, see, it is connected to battery. As soon as it is connected to battery, this plate will become, since it is connected to positive terminals of the battery, so this plate will become positively charged. So positive charge will accumulate here. It is connected to negative terminals of the battery, so negative charge will accumulate here and this plate will become negatively charged. Okay, now when a conducting slab of thickness T is introduced between two capacitor plate, then what will happen? Okay, separation between the two capacitor plate is, suppose it is a small d. Okay, external electric field means when now initially what was electric field, so this E0 be the external electric field when nothing was inserted, before inserting E naught with the electric field. Okay. Now when we insert conducting slab, see, we know inside conductor electric field is 0. So this is also conducting slab. This is what? Conducting slab. This is conducting slab. So when we introduce the inside conductor, electric field is what? 0. Okay. Inside conductor electric field is 0. And so I am going to calculate the capacitance. Okay. Let V be the potential difference, between two capacitor plate, Okay, V with the potential difference between two capacitor plate. So see here, V is equal to electric field into separation distance between the two plate. So see, it will be E naught, okay, D minus T, D minus C. See, total is D. This much is T. This much is T. And to separation between two capacitor plate is D. So this space will be what? D minus T. Okay. And this is what? Electric field. This becomes 0. Inside conducting slab electric field is 0. So E into T. Okay. So it will be E into T. But inside conductor electric field is 0. Inside conductor electric field is 0. So V is equal to external electric field D minus T. Only this. Now, what is the electric field between two capacitor plate? What is the electric field between two capacitor plate? So it will be sigma by epsilon naught. Okay, this will be D minus T. Correct. Sigma by epsilon naught. This is sigma by epsilon naught, and sigma into D minus T upon epsilon naught. Okay. Because we know what we know, E is what? Sigma upon epsilon naught. Okay, you know it. Understood? Now sigma is the surface charge density. So we will write Q by A epsilon naught D minus T. Okay, because surface charge density is what? Q by A. Okay, surface charge density is total charge by area of the surface. Okay, surface charge. Now, so we put V. Okay, now C is equal to what? C is what? Capacitance is charge by potential. Capacitance is equal to C by V. So C is what? C is equal to Q divided by V. V is what? We put the value of V here. V Q D minus T into A epsilon naught. Okay, so it will be what? A epsilon naught divided by D minus T. Okay, now we can take common A epsilon naught. So see, A epsilon naught, D here common, so it will be what? 1 minus T by D, correct? Now when we introduce even the conducting slab, see, capacitance will be A epsilon naught D minus T, so it is less than D, so capacitance increases. When we introduce, either we introduce dielectric slab or conducting slab, capacitance of parallel plate capacitor increases. Okay, now we will take common D, so it will be A epsilon naught D. So A epsilon naught by D is what? It was original capacitance. It was original capacitance. So C is equal to C naught, where C naught is the original capacitance, divided by 1 minus T by D. So when we insert conducting slab, C, so C is equal to C naught 1 minus T by D. Okay, now so when we introduce conducting slab, then also capacitance decreases. Okay, now when the conducting slab completely fill the space between two capacitor plate, then what will happen to capacitance? Okay, that I am going to explain. So C is equal to when C, when T is equal to D, means when the conducting slab completely fill the space between two capacitor plate, then what will happen when T is equal to D? So C will be what? C naught, initial capacitance of parallel plate capacitor. Now 1 minus, this will be what? D by D. So it will be C naught by 0. Now according to mass, 1 by 0 is infinite, so it will be infinite. That means capacitance of parallel plate capacitor becomes infinite large when conducting slab completely fill the space between two capacitor plate. So see what is happened here. C is equal to, C becomes infinite. That means when conducting slab completely fill the space between two capacitor plate, then new capacitance of parallel plate capacitor becomes infinite. It will become infinite. How much? It will become infinite. So here capacitance becomes infinite. This here. Okay. So when we insert conducting slab of full depth, which completely fill the space between two capacitor plate, capacitance will become infinite. Okay, so for today up to this. Okay, thank you so much.